All right, well, we are on the very last section of this chapter with lesson 2.7. And in this lesson, we're going to learn about two different types of variation models. One is going to be just a plain old inverse variation, and the other one's going to be an inverse square variation. Now, there's some similarities, but there's also some differences. So we'll talk about those as we get to the second part here in a minute. But to start out with, when we have something in the form y equals k over x, the way that we phrase that is we would say that y varies inversely as x. And k is what we call the constant of variation. K is always going to be a number, so we wouldn't ever see k as our actual equations. We would see k being replaced with some kind of number. And we call that number k the constant of variation. And it can be any number except 0. It cannot be 0. Now when we graph equations in the form y equals k over x, the shapes of these graphs are called hyperbolas. And they have both a horizontal and vertical asymptotes. Remember, an asymptote means that those lines get really, really close or approaches those values, but it will never actually be on those values or be on those lines. So the asymptotes here for just the general form would be at y equals 0. That would be the horizontal asymptote. So right along the x-axis would be y equals 0. And the vertical asymptote, straight up and down, would be at x equals 0, or right on top of the y-axis. So those would be where our two asymptotes would be if k was a positive number. But if you see in the second graph there, if k is a negative number, we still have the same asymptotes, but the graphs are in quadrants, instead of being in quadrants 1 and 3, it's in quadrants 2 and 4. Now, there's a 4-step process that we're going to use to solve a variation equation. And this is true for both parts of today's lesson. So the nice thing is these 4 steps are going to be the same 4 steps that we're going to use in the second half. But the first step is to find what we call a general equation. Just a general equation. So that would be y equals k over x or y equals k over x squared. And oftentimes, if we're dealing with a story problem, instead of x and y, we might use the letters that pertain or apply to a particular story problem. But then the first real math that we're going to do is we're going to find k using specific values. So whether it's a story problem or whatever the case is, they're always going to give us a coordinate. They're going to give you a value for x and a value for y. And so we can use that value for x and y to find our value for k in that specific scenario. And after we find k, well, then we can change that general equation into a more specific equation. Like if I know that k is 3, well, now I can say that my equation is y equals 3 over x. And then I can use that equation to answer whatever the question is asking. So let's look at some examples here. So here it says, according to Boyles' law, the pressure of a gas varies inversely as the volume. In a chemistry lab, you collect data on the pressure and volume of a gas. All right, let's stop there for a second. When we're dealing with these problems, it's important to note what it says. Okay, now right now it doesn't seem like that big of a deal, but after the second half of the lesson it will. So here it's just saying the pressure of gas varies inversely as the volume. Okay, so we see that phrase varies inversely. When we see that phrase varies inversely, what we can do is we can just say, oh, that's always going to equal k divided by. Now, other terms that we might use instead of varies inversely would be varies proportionally or is inversely proportional. So there's other phrases that we might use, and we'll come across those as we go along. But otherwise, that piece represents the phrase equals k divided by. So then to the left of that, we see the pressure of a gas. So we can decide what we want to use for our variable. If you want to use g, or we could use p. I'm going to use p for the pressure. So p varies inversely as the volume. And it doesn't say anything about the square of the volume or cube of the volume, so just plain old volume. So when it says find a formula relating the pressure and volume of the gas sample you studied in the lab, we can follow those same 4 steps. So technically we're going to stop for this one at the third step. Because the first step is what we just did. The first step is to write a general equation. So it's going to be p equals k divided by v. And I want you to write it as a fraction. Don't use this divide symbol when you actually write the equation out. So we'll do p equals k divided by v. Now in this scenario, we have a whole table of values. Okay? I could use any one of these pairs. These are all ordered pairs where the volume would be our x and the pressure would be like our y. And so I could treat, like I said, all these as coordinates and plug these numbers in. So just to be consistent though, so we're all using the same numbers, let's use the 60 and the 84.6. So we're going to use that. So that's going to be our specific value that we're going to use to find our value for k. So that brings us to our second step. So our second step would be to plug these numbers in. So we know the pressure is 84.6 when the volume is 60. So to find what K is, we would multiply both sides by 60, which would give you 5,076. Now, if we had used a different pair of numbers, now remember this is a model. A model does not always fit perfectly to a particular equation or a particular line. So you might have used 80 in the 64.2, and you'll have a slightly different value for K. And that's all right. In the big scheme of things, it will not matter. So just know that you might have, or your value for K will differ. Now, it should differ only slightly. It shouldn't be a big difference, but it should only be slight differences here. So now we can do what the question is asking. The question for this is asking us just to write an equation, a specific equation to model this data. So instead of, we're done with the 84.6 and 60 at this point because we got what we needed. We got our value for K. So our equation would be P equals 5,076 divided by the volume. So now we can use those values, that equation, to answer whatever question they might ask. So in this one, in the next part of the question, it says what volume corresponds to a pressure of 40 kPa or kPa. You don't have to worry about the units there. But we're going to put 40 in, but we got to make sure you put it in the right spot. Okay, so they were trying to find the volume. So it says what volume. So we know that this is going to be our pressure. So I'm going to set up the equation to look like this. It'll be 40 equals 5,076 divided by V. Now, this is where people always have a hard time. They always wonder, all right, what do I do to solve this? Do I divide both sides by 5,076? Do I multiply both sides by 5,076? Do I take 5,076 divided by 40? None of those are correct. Okay? Here's what we want to do. We want to get rid of the fraction. In the fraction, I have the V in the denominator. So I'm going to multiply both sides by V. Doing so gets rid of the V from that denominator. So now I have 40V equals 5,076. Now I can divide both sides by 40, and when you do that, we get 126.9 as your answer. Now, there is a shortcut. Now, out of anything, there's only one shortcut that we could do. Now, if you don't feel like you can remember this shortcut, don't do it. But anytime we have a variable in the denominator and something over here, if we just switch those two around, we would get, because notice what we did here, is we took 5,000, at this point here, we would have taken 5,076 divided by 40. So that's the only thing that we could do. We could switch those values to say 5,076 divided by 40. And I take back, I guess earlier I did say that you would not divide by 40. What I meant to say is we wouldn't take 40 divided by 5,076. But this would be an alternate way to get that answer. But otherwise, if you can't remember this trick, or if you're ever not sure, the way that you would go about solving it to get directly to your answer would be to multiply both sides by whatever is in our denominator. In this case, that would be V. So then we'd get V times 40, or 40V equals 5,076, and then divide by 40. But regardless, you get 126.9 as your final answer. All right. So here's another scenario. Here it says the average song size and approximate number of songs for a sample of 32 gigabyte MP3 players are listed in the table below. Now this is an old story problem. You guys aren't maybe even familiar with what an MP3 player is. So back in my day, we didn't have the ability to just store a ton of songs on our phones. There was no such thing as Pandora or Spotify or even the cloud where you could store all your songs. You had to store all your songs on a portable device called an MP3 player. And it was limited by you're limited by how many songs you could have on your device based on, obviously, the storage capacity. So here we have a 32 gigabyte MP3 player. And if you have the average song size is 4.1 megabytes, then you could store 7,800 songs on the device. So what we're going to do, though, is I want you to come up with do the same four-step process. So the first step is to come up with a general equation. Now, it does say the average song size. Oh, I forgot. I think, let's see. Okay, so it doesn't say directly in here. There is a piece, I remember now with this story problem, I left out a key portion. The key portion here is that the number of songs is inversely proportional to the song size. Okay, so the number of songs is inversely proportional to the song size. Okay, so I want you guys to set up your own equation. Now, if we use S for the size of the song, you don't want to use S to represent the number of songs. So I would use N to represent the number of songs. Might make it a little easier. Anyhow, why don't you guys go ahead and set up this equation then based on that information and based on the information from this table. And I would recommend using the coordinate 4.9 and 6,500. So in that way, your value for K will match up my value of K that I came up with. So go ahead and pause the video and work through that 4-step process for this problem. All right, let's see how you did here. So again, in this one here, you didn't actually have to do the 4-step because there is no question. There's no follow-up question saying like what would be the approximate number of songs if the average song size was 3 megabytes. Okay, they didn't ask that. They just asked you to write an equation. So the equation here, once you find out the K value is 31,850, you get your equation then as N, the number of songs, is equal to 31,850 divided by the size of the song, or S. So hopefully you got that equation. All right, so that ends that first part of the lesson. Now let's look at the second part. Now the second part is going to deal with what we call inverse square relationship. So these are in the form y equals k over x squared. Or if you wrote it without a fraction, it would be k times x to the negative second power. But 98% of the time it's going to be k over x squared. Now the graph of this one is going to be different from the previous version. Okay, k over x had what we call 2 branches. That's what we call those. Where a branch was in the first quadrant and the third quadrant was k divided by x. And with this one, k divided by x squared, it's going to be in quadrants 1 and quadrants 2. Now, I want to give you a little trick to help keep these straight. If you think of an equation of the form y equals k times x squared, that's going to be a parabola. And a parabola is connected, and it's this U shape that's connected in quadrants 1 and 2. Now, if you think about what division implies, division, if you have division in any relationship, it means that in that relationship, it's going to be split up. So that's what division does. It causes it to be split up. So instead of having those two, or that parabola, those two pieces connected, when you have division, it's going to break it up into 2 separate pieces. Okay, so that's what the division does. It takes that parabola and splits it into 2 pieces. And that concept even works for an equation in the form y equals k times x would be a straight line. Okay, and that's connected between quadrants 1 and 3. But if we had y equals k divided by x, so if we created division there, it's going to take that line and break it up into 2 separate pieces. So those pieces are still in quadrants 1 and 3, but they are no longer connected. So that's the way that I always kept this straight, so hopefully that would be a trick that will help you out as well. All right. So the nice thing is that same 3 or 4-step process is going to be the same process that we use here, except for our general equation we start out with might be k over x squared instead of k over x. So let's look at this example here. It says the force exerted by the electrical field between 2 charged objects is inversely proportional. Okay, so here we see that phrase. So it's going to be equals k divided by to the square of the distance between them. Okay, so here we have that word square in here. So that tells us that it's going to be k divided by something squared. So to the left of that equals k divided by, we have that huge sentence, but it's talking about the force. Okay, the force exerted by the electrical field between 2 charged objects. So it's referring to the force. So I'm going to say my first step here for my general equation would be F equals k divided by something squared. And it's the square of the distance between them. So it's going to be d squared. So that square is super important. If you don't include that, you're going to get the wrong answer. So the second step, we're going to find out our value for k using a specific scenario. Well, let's read on. It says, at a distance of 1.5 meters, you measure a force of 30 newtons. So that tells us that they gave us a distance and they gave us a force at that distance. So you need to put these in the right spot. So it'd be the 30 is our force. So our force is 30 when the distance is 1.5. So here we're going to square that 1.5. Now to solve for k, remember earlier I said we just always, to get rid of the fraction, we always multiply by whatever's in the denominator. So we do the same thing here. So to find out what k is, you can just type in your calculator 30 times 1.5 squared. And when you do that, you get your value for k, which is 67.5. So there's your value for k. Whoops. So now let's go to the third step. So our third step is to write our general equation. Our general equation goes back to what we had here at the beginning. We're only just going to plug in this value for k up on top. So it'd be f equals 67.5 divided by d squared. So now we can use that equation to answer the question. So the question, there's two questions here. It says, what will the force be at a distance of 3 meters and a distance of 15 meters? So let's start with the first one. So the first part there, we would say f equals 67.5 divided by 3 squared, or 9. And when you do that, you end up getting an answer of about 7.5. Anytime we measure force, it's in newtons. So we would just say 7.5 newtons. And we get that right here. It says even that we had a force of 30 newtons. So to figure out the second part, to figure out what the force would be when it's a distance of 15 meters, we just do the same exact thing using that equation. So that's the purpose of having that equation. So now I can just plug that distance in, the 15 in. So we would have 67.5 divided by 15 squared is 0.3 newtons. So those would be your two answers for that question. All right. This last example, you're going to do the same idea. So it says the intensity of light from a point source is inversely proportional to the square of the distance from the light source. So read that very carefully. Suppose at a distance of 5 centimeters, the light intensity is rated at 600 lumen, or lux is how we refer to that as a unit. What will the intensity be at a distance of 10 centimeters and at a distance of 23 centimeters? So just like the previous example, you're going to have two answers when you get to the end. So I want you guys to go through this 4-step process for this problem. So you'll want to pause the video. And I want you then to hit play when you're ready to check to see if you did it correctly. All right, you should have gotten 150 lux and 28.4 lux. If you didn't get that, make sure you didn't make any mistakes as you went along. Notice what I've been doing here with all of my work. I labeled each individual step. I would strongly recommend you doing that. It just makes it easy to go back and check, especially if you do your work horizontally like this, because then as my eyes scan from left to right, I can easily see if I missed a square. So if over here in the second step, if we forgot the square, if I had k divided by 5, that would be an indicator that, ooh, I didn't carry my square through. I missed something. Or even if you forgot the square over here, if we had 15,000 divided by d as my equation, I'd recognize that, oh, that's right, this is supposed to be the square of the distance, so it's supposed to be d squared. So the more organized your work is, I find that the more successful you'll be at getting the correct answers. But hopefully this answers your questions now as you get a chance to see what the inverse variation model looks like and the inverse square variation model looks like. And so make sure you come to class tomorrow ready to do the warm-up and work on your assignment.